So this question from electromagnetic theory says that consider the propagation of electromagnetic waves in a linear, homogeneous and isotropic material medium with electric permittivity epsilon and magnetic permeability mu. So for a plane wave of angular frequency omega and propagation vector k propagating in the medium, Maxwell's equations reduce to one of these four options. So k dot E, k dot H, k cross E and k cross H we need to find out, and then one of these four options right here would be correct. So before proceeding, let us write down our Maxwell's equations for a medium. So we have Maxwell's equations. So first equation is del dot D, then next equation is for del dot B, which is equal to 0. Then we have curl of E and how it's related to the time derivative of magnetic field, and then curl of H and its relation to the time derivative of electric field. So now for the medium, we have this electric displacement vector D written as epsilon times E, and B is mu times H. Now why these relations are true? This is true only for a linear medium, and we are given that we have a linear medium right here. So this is a linear medium, and you can write since it is plane waves, so we have plane waves. So in that case, we have electric field given as some amplitude times the e to the power I k dot r minus omega t. Then similarly for the magnetic field, and from B and H the relation is there, and you will see that we can also write H as follows. So these are the expressions for the plane waves of angular frequency omega and propagation vector k that is given to us. Now we can write each of these amplitudes, this E naught, in terms of components like E naught x along the x cap direction, E naught y along the y cap direction, and E naught z along, sorry, this z should be in the subscript, E naught z along the z cap direction. Similarly, you will have a components. You can write down the components for B naught, for H naught. You can write down in terms of components for along x cap, y cap, and z cap. The k vector, also it will be kx along x cap, ky along y cap, kz along z cap, and the r vector is going to be as follows. And hence our k dot r is going to be like so. So this is the k dot r that we have. And now we will look at each of these four Maxwell's equations, and we will try and plug in these expressions for E and B, and then see which of these options turn out to be the correct ones. So you can see that k dot E and k dot H is 0 in all of these options. So we do not necessarily need to check them. So because it's an MCQ question and it is time bound MCQ question, you need not start by checking k dot E and k dot H. You could simply start by working out k cross E and k cross H, because that is going to give you the answer. But for the case of understanding and for the case of understanding the concepts, I will solve each of these four Maxwell's, basically I'll plug in each of these expressions for E and B in the four Maxwell's equations that we have, so that you understand exactly what is going on. So let us start with the first Maxwell's equation. So first Maxwell's equation is del dot D is equal to 0. Why? Because the charge distribution, the free charge distribution that we have in our case is 0. So let us now basically plug in these expressions that we have written down. So del dot D equal to 0, and D is nothing but epsilon E. So this is equal to 0, and we can take this epsilon out. So epsilon del dot E is equal to 0. And why can we take it out? Is because we are given that we have a homogeneous medium. So we are told that it's a homogeneous medium, homogeneous isotropic medium. That means this epsilon is not a function of the spatial distribution, the spatial location. So epsilon is a constant all throughout the medium. That is what it means. So let us proceed now. So this means that del dot E is equal to 0. Okay, so this is what we have, and let us now just plug in this expression for E that we have written down. So this means that 0 is equal to del by del x E naught x e to the power I k dot r minus omega t plus del by del y e naught y e to the power I k dot r minus omega t similarly del by del z minus omega t. So this is what we have, and we need to basically expand this and find out the derivative. So it is pretty simple. So you would see that del by del x of this. So let me actually first expand the k dot r term for you. So k dot r is nothing but kxx plus kyy plus kzz minus omega t. So I'm just expanding this k dot r term everywhere. Now you see that del by del x, look at this first term. So when you differentiate with respect to x, you get ikx term outside. So what you get is e naught x is a constant and ikx is what comes out from the derivative, and then rest of it is as it is. Similarly, over here, what will come out is I times ky, and e naught y is a constant. and similarly for the last term. Now you notice that this big expression is nothing but I times k dot e. So why I say that? See, I you can take common from each of these three terms, and the remaining term is nothing but k dot e. Kx times e naught x, and this exponential term is same for all. Ky times e naught y, and this exponential term. Kz times e naught z, and the exponential term. So this is nothing but k dot e, and this I term is there in all of them. So what you get is del dot e is equal to I k dot e, which is equal to 0, which implies that k dot e is equal to 0. So from the first equation, we get k dot e is equal to 0. Now we will focus on the second term. So similar to how we focused on the first Maxwell's equation, similarly we will focus on the second Maxwell's equation. So next, so we will start by this. So now you see that we had written that B is nothing but mu times H. So del dot B is nothing but del dot mu H, which is equal to 0. And again, we can take mu outside. And why we took it outside? Same reason, this being a homogeneous medium. So this is a homogeneous medium. That's why we can take mu common outside. And so let us just solve it similar to how we did for the previous equation. So similar process we are adopting over here. What we did with electric field, we are doing the same thing with magnetic field this time. And again, you can see that I can expand it for you. So h naught x e to the power I kx x plus ky y plus kz z minus omega t. And similar for the other terms, I will not write down the other terms, you can write it down yourself. So similarly, it's just expanding this exponential term. So again, now when you take the derivative with respect to x, what you get? You get this I kx term outside. So h naught x is a constant, then I kx and e to the power I kxx plus ky y plus kz z minus omega t. And similarly, you have for the other terms, this time it will be I k y which comes out, and then the exponential, and similarly for the z and the exponential. Exponential is same throughout. Now what you would notice is this is nothing but I k dot h, just like it was I k dot e in the previous case. This time around it is I k dot h. So what we get is del dot b is equal to I k dot h, which is equal to 0, which implies k dot h is equal to 0. So indeed, in the options that you see, all of them have k dot e is equal to 0 and k dot h is equal to 0. So that means everything is consistent and correct. Now we will look at the third Maxwell's equation. So del cross E is equal to minus del B by del D. Now, if you remember how to find out the curl, it is, we write this big determinant out here. So x cap and del by del x, and then E naught x e to the power I kxx plus kyy plus kzz minus omega t. Then you have y cap del by del y e naught y and same exponential. Then you have z cap del by del z e naught z and the same exponential. I'm not writing the exponential again and again, so you can just copy and write down the same exponential again. So expanding this determinant, what you get is first term x cap, so del by del y e naught z e to the power I kxx plus ky y plus kzz minus omega t minus del by del z e dot y e to the power I kx x plus ky y plus kz z minus omega t. Then minus y cap. So this is the determinant. So you have first x cap and then these terms, then you will have minus y cap, and then you would take del by del x of e naught z e to the power I kxx plus ky y plus kzz minus omega t, and then minus del by del z of e naught x e to the power I kxx plus ky y plus kz z minus omega t. And finally, you have the last term, which is with z cap. So this is the expansion of the determinant to find curl of E. And you can find out these derivatives. They are pretty simple. So for the first case, what comes out is I times ky. This is del by del y. So what comes, and e naught z is constant. So what you get is e naught z I times ky and exponential I kxx plus ky y plus kzz minus omega t. And from the second, what comes out is kz, I kz comes out. So you have minus e naught y I kz and the same exponential. I'll not write it again. So same exponential. Then minus y cap e naught z, this time I kx comes out because it is del by del x. So I kx will come out. And then the exponential Then you have E naught x I k z and the same exponential. Finally, for z cap term, now if you notice that these terms you take I common out, and what remains inside is nothing but k cross e. You can write down this determinant for k cross e how you would have. So k cross e here you would have kx, ky, kz, and the last row would be the same. And if you work that out, you would realize that this expression right here, this thing right here, is nothing but k cross e times I. So this is what you get for curl of E. And for the right hand side of this equation, we have minus del B by del T. So if we work that out, this is minus del by del T of B naught e to the power I k dot R minus omega T, which is nothing but this time minus I omega will come out. So you have minus I omega coming out, B naught e to the power I k dot R minus omega T, which is nothing but I omega B. So what you have from the third Maxwell's equation is del cross E is equal to minus del B by del T. This means, and del cross E is nothing but I k cross E. That means I k cross E is equal to, and minus del B by del T is this I omega B. Oh, sorry. Yeah, sorry. This is not minus, this is plus only. I said minus. If I said minus, this is plus. So I k cross E is I omega B, and cancelling out I from both the sides, you get k cross E is equal to omega B, and B is nothing but mu times H. So you get the following: k cross E is equal to omega mu H. So this is from the third Maxwell's equation. Now, similar thing you would do with the fourth Maxwell's equation. This time we have curl of H instead of curl of E. And why this? Because the free current is 0. So JF is equal to 0. And I can write down the determinant form for finding out this curl. Pretty much similar to what I did for curl of E. So you have x cap del by del x h naught x e to the power I kxx plus ky y plus kz z minus omega t, then y cap del by del y, same exponential term, and then z cap h naught z, same exponential term. And you can expand this determinant just like we did previously. So let me quickly do it right here. So x cap del by del y h naught z, and then the exponential I kxx plus kyy. So this is for x cap, then negative y cap. Same exponential term again. and finally z cap term. And similarly, you can just find out, you can just get these derivatives. These are pretty much simple, just like we have seen. So you would have iky coming out from here, ikz coming out from here. So I would just quickly write it down. Then the exponential term, then minus y cap, and then z cap. So similar to the previous Maxwell's equation, you would notice that this is nothing but I times k cross h. I is common all throughout in all these terms, and the remaining part is k cross h. So the right hand side of the fourth Maxwell's equation is del d by del t. And quickly, if we find that out, d is nothing but epsilon e, and epsilon is constant taken outside. So what comes out from the time derivative would be minus I omega. So epsilon minus I omega, and the remaining stuff is as it is. So this is nothing but minus I omega epsilon E. So what you get is del cross H is equal to del D by del T. And del cross H we found is IK cross H. So this solves the question. And if you go back to the options, going back to the options, you would see that option number D is the correct option, where k cross E is omega mu H and k cross H is equal to minus omega epsilon E. So instead of doing all this big algebra, I have a small trick for you. A trick which can basically be used to arrive at all of these expressions in a faster, quicker manner. So I'll write down the trick for you so you can use this trick to solve the question. So the trick is that you replace your curl or gradient, basically this del operator, by the vector ik, and you replace the time derivative by minus I omega. So if you use these, you would see that immediately you would arrive at the expression. So del dot d is equal to 0 implies I k dot d is equal to 0. You get the first expression right away. Del dot b equal to 0 implies ik dot b is equal to 0. Del cross E is equal to minus del B by del T gives you ik cross E is equal to minus, so minus of del B by del T, and del by del T is minus I omega times B. Again, you come at the equation right away. And finally, the last one. So this trick can be used to solve the question faster. But now, since I worked down the maths, you realize that why we can use this trick. So the maths is the real thing. This trick is based on the maths that we have just worked out, the full algebra, the full stuff that we have done. But once you have done that, you can keep this trick in your mind. So after you have solved this entire mathematics, you can keep this trick in mind, and then you can now solve the question much faster. You see, just by using this, I arrived at all these four